Assalamu alaikum dear students. In today's digital system design lecture we are going to start from Dataflow Modeling. Lecture objectives include describe the continuous assignment statement, restrictions on the assign statement and the implicit continuous assignment statement, explain assignment delay, implicit assignment delay and net declaration delay for continuous assignment statements, define expressions, operators and operands, list operator types for all possible operations, arithmetic, logical, relational and other operators, use Dataflow constructs to model practical digital circuits in Verilog. Now starting from introduction, we have studied gate level modeling, which is practically used for small designs. Now next level up, Dataflow modeling. For small circuits, the gate level modeling approach is good because number of gates are limited and designer can instantiate and connect every gate individually. Other benefits include gate level modeling is used with very basic level of digital logic design. However, in complex design the number of gates are increased, so designer can design more effectively if they can use higher level of abstraction than the gate level. Dataflow modeling provides a powerful way to implement a design. Now logic synthesis is a tool which is used to create a gate level circuit from a Dataflow design description. Here you see that we are designing in Dataflow level and through logic synthesis process we can create gate level circuit from Dataflow design. Now RTL, known for register transfer level, is commonly used for combination of Dataflow modeling and behavior modeling. Now starting from continuous assignment statement, this statement known as continuous assignment is used to drive a value onto a net. Please note that this is used to drive a value on a net data type. This assignment replaces gates in the description of the circuit and describes the circuit at higher level of abstraction. The keyword used for continuous assignment is known as assign keyword. Here this example is about assign this out variable. This assign keyword is used to assign these operations to this out variable. Now there are some rules for assign statement. First, that you have to note that left hand side data type should only net data type and right hand side data type may be register, net or function. You are free to choose, but left hand side should be only net data type. These are some examples here. Out should be net data type and these are net or other data types, but out should be net data type. Here this variable known as address of 16-bit should be net data type and these may be net or other variable, and here concatenation is used, but sum and cout should be net data type. Now another type of assignment statement is implicit continuous assignment. Here this is another method in which a continuous assignment can be placed on a net when it is declared. Please note that this implicit assignment is used at the time of declaration, and it is also be used on net data type. There can be only one implicit declaration assignment per net because a net is declared only once. This is the example. Here you see that this is regular continuous assignment, wire out and assign out. This is the regular continuous assignment, but this is the implicit continuous assignment. Here you see that we have declaring out variable as wire data type, and at the same time we have implicitly assigned this in1 and in2 to out. Here you see that we don't use the keyword assign, but this is implicitly assignment of this execution to this variable out. नेक्स्ट जो है implicit net declaration. In this net declaration, if a signal name is used to the left of the continuous assignment, an implicit net declaration will be observed. And if the net is connected to a module port, the width of the inferred net is equal to the width of the module port. Here you have to notice that, as the name suggests, implicit net declaration. At the time of declaration, implicit assignment. Let's see some example. Here I1 and I2 are declared as wire data type, and out is not declared anywhere, but implicitly by the simulator it is assigned as wire data type. As you see that when we use assign, then out is implicitly declared as wire data type. Now here we have discussed some delay types. Delay values control the time between the change in right hand side operand and when the new value is assigned to the left hand side. There are three ways of specifying delays, such as regular assignment delay, implicit continuous assignment delay, and net declaration delay. This is the regular assignment delay. You have to note that in this type of assignment delay value is specified after the keyword assign. Here you will see in this example that after the keyword assign, this delay is used. And how this command is executed: any change in values of in1 and in2 will result in a delay of 10 time units before recomputation of the expressions in1 and in2, and result will be assigned to out. When any one of the value of input 1 and input 2 is changed, the result will be updated to out after 10 time units delay. This property is also known as inertial delay. Now here an important concept is discussed, that if the input pulse is shorter than the delay of the assignment statement, then this input change does not propagate to the output. Let's see here. This is the waveform of the input, and here it is for output. This is for input. The out is the AND operation of in1 and in2, and here you see that as the out variable have the delay of 10 time units, so the output will be available after 10 time unit, and from 0 to 10 out value is the X value, which is also known as unknown value. Here you see that after 0 to 9 at 10 time units the output will equal to 0, and here at 20 time units input 1 and input 2 both are 1, but output is still equal to 0 because of this 10 time units delay, and this change in input is observed after 10 time units at the time of 30 time units. Here you see that at time 60 input 1 goes to 0, but input 2 is equal to 1, but the AND operation of these two inputs is equal to 0, but at time 60 output still equal to 1 due to 10 time units delay. So this delay, due to this delay, output will goes to 0 at time 70 time units. So this change occur after 10 time units at here. Now this is an important concept. At time 80 to 85 input 1 becomes 1 and input 2 is already 1, so output should be equal to 1, but here you see that output, due to delay, output remains 0, and this input change will be occur after 10 time units, and this is 80, so at 90 this input change will occur. But here we have studied that the output is updated at the time of recomputation. So at 90 computation is done from the immediate inputs. As you see that after 85 it will again become 0, so AND operation of these two inputs is equal to 0. So at 90 time units we have got the variable out as 0, because here at 90 the recomputation of the inputs both are 0, and this small input change is not propagated to the output due to this concept that if input pulse that is shorter than the delay of the assignment statement does not propagate to the output, because input pulse width is 5 time units and delay is 10 time units, so this small input pulse is not propagated to the output. Here you see the details are given that width less than the specified assignment delay is not propagated to the output, and at 90 time units we still have the output equal to 0. Now next you will see implicit continuous assignment delay. In this type of delay, this is an equivalent method. Here specify both delay and assignment on the net. Here you see that as the word suggests implicit in the name, that implicitly assignment are done. Here you see that no assign keyword are used, just use the while and delay is used, and implicitly these operations are assigned to the keyword, to the variable out, and keyword is where. So this is implicitly these statements are assigned to the variable out. This command is same as first we declare variable out as a void data type, and then we assign out n1 and into operation with the delay. The declaration above has the same effect as defining a wire out here and declaring a continuous assignment on out. These two commands and this command are equivalent. Next, net declaration delay. In this type of delay, a delay can be specified on a net when it is declared without putting a continuous assignment on the net. As the name suggests, this delay type is used at the time of declaration of nets. For example, if a net out is used, then any value change in the net is applied to the net out accordingly. Net declaration delays can also be used in gate level modeling. Let's see in the example. Here you see that we are declaring out as a void data type, and also at the time of declaration we have used the delay of 10 time units, and after that we have assigned this out variable with this in1 and into operation. This statement is equivalent to first we declare out as void and then we have used the delay. But please note the difference that in net declaration we are using the delay at the time of declaration, and this delay is used in all the operations where the out is used accordingly. But here we have to explicitly define the delay in all the commands. Thank you.